Hey y'all, ready to learn? I'm ready to learn. This week I'm doing something kind of weird. I'm going to actually be doing the math with you, and I'm not giving you a second option. You're taking notes with me today. So I'm on page 3. This is a 1C. It's the segment addition postulate and the angle addition postulate. Have you ever heard the word postulate before? Probably not. This is the first time you're hearing it. So a postulate is something that we assume to be true. Now, there's a whole rant I could go on, and I probably will be at some day, about how we can't always assume it to be true and sometimes it's not true, but I'm going to show you why these are true, at least in our case. So postulates assumed to be true. There's this thing called the segment addition postulate, which in our books is section 1.2. Did I do some magic there? I sure did, and you're okay with it, I bet. If you want to look at section 1.2, you can read the segment addition postulate. I don't find it to be that riveting of an explanation. I'm going to show you it in pictures instead. But we are at some point in geometry going to get to the point where the words of the postulate are actually super important. So don't think it's going to happen like this all the time. So I'm going to draw you a picture, and we're going to write out the segment addition postulate right now. Ta-da! It says that if B is between A and C on line AC, then A to B plus B to C equals A to C. Oops, sorry. Y'all, whiteout's a miracle worker, let me tell you. So let me break this down for you, though. I'm going to grab some colors because I like colors. Why not? Get used to it. All right, so A to B. Let's say A to B is this color. A to B is this section of the line. And then I need a different color. There we go. And then B to C is this color. It's this section of the line. If I were to add up those lengths, they do indeed equal the total all the way from A to C. Okay? The length from A to B plus the length from B to C is equal to the total. Duh, right? That's why it's called a postulate. We assume it's true because it kind of is. We don't need to prove that it's true. Newsflash. In geometry, we are going to be doing things that we have to prove are true before we can use them. That's called proofs. It's a whole section. It's coming up this trimester. But don't stress out about it. We're going to get through it together. It's a stressful time, and you'll ask people if they like proofs, and they'll say no. But it's okay. We'll figure it out. So let me draw an example. Ta-da! In this first example, W is between V and U. So we can use the segment addition postulate, which says that this section plus this section equals the whole. That's all it says. So we're going to set up a equation. So for right now, V to W, let's call it X. You can't read that. Let's do a different color. Let's call it X in pink. Please stand by. We're going to call it X in blue. So what we know from the segment addition postulate is that X plus 8 is going to equal 31. What does that look like to you? That looks like algebra to me. I'm going to subtract the 8. Uh-oh, I don't think I wrote this down already. 31 minus 8. I know that 31 minus 10 would be 21, so that's 2 away, so it's 23. So now I know that instead of writing X, normally we write what VW is. So therefore, VW equals 23. If you want a different example, I'm going to give you one right now. You try that one. Pause me. Okay, great. You tried. V to W right here is the whole thing. So I would do 30 plus 65 to find this length, which would be 95. Did you get it? If so, good job. If not, email me. I'll give you more examples. Next. Okay. Let's talk about the angle addition postulate. I also added a little book symbol up here to represent that this is where it is in our textbook. It's not the number of the postulate or anything like that. So the angle addition postulate is very similar. Again, if you look in section 1.5, you will absolutely find way too many words. It says something about having a ray be on the interior of an angle and blah, 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 and we don't care. So let me draw you a picture instead. Let me really quick inform you about this verbiage right here. So M, we read the measure. And then this is specifically the measure of angle RSP. That's how I say it out loud. It's the measure of the angle. It's not the angle itself, because the angle just sort of exists, but the measure of the angle. So let's color code again. Booyah. I'm just going to label it like this. I'm going to label this angle is this angle right here. That's RSP. And then this angle is this one over here. Those are not the same, so I have to do 2 marks because I don't want to insinuate that they're congruent. That would be bad. So what this is saying is that if I add up the pinkish angle and the blue angle, it'll be the total, right? The pink angle and the blue angle equals the total angle. That makes so much sense. That's why this is called a postulate. I don't need to prove it to you. You can see it with your own 2 eyes. Let's do an example. Boom. So what this is giving us is it's giving us a pretty picture, if I do say so myself, with, they kind of go in a circle here, PQRS, if I label it that way. And what this is saying is that this angle right here, PQS, is 9x minus 11. And this angle right here, SQR, is 7x minus 5. It also tells me that the total, the largest angle is 102, and I want to find the measure of angle SQR. I want to find this angle right here. Now, if I just say it's right here or it's 7x minus 5, that's not a complete answer. We're going to find the measure of it, the numbers that it is. Okay, so what I know is that I know that these 2 added together equals the total, right? That's how it works. So I'm going to add these together. I'm going to go 9x minus 11 plus 7x minus 5. Now this section right here is from this, and this section right here is from this. I add them together. Sometimes, and this is kind of optional, sometimes you'll see it done in parentheses to separate out the 2 parts. This plus this. And they add up to make 102. That looks like algebra again. Let's do some more algebra. Now the first one I did was much simpler than this, so I'm going to walk through it a little bit slower, just in case your Algebra 1 teacher went too fast or something, or it's been an entire pandemic, so you forgot everything. So I want to first of all collect like terms. So 9x and 7x I'm going to add together into making 16x. And then negative 11 and negative 5, I'm going to add those together to make negative 16. I can tell I'm going to need a calculator. Oh, I might not. We'll be good. Okay, so next up, I'm going to add the 16 to both sides. I did this in a color last time, but it's fine. I'm going to add this 16 to the 102. So I get 16x equals 118. And I'm going to divide everything by 16. So x equals, that's where I'm going to need the math. Hold on. It's a gross number. And I'm going to tell you why it's a gross number. On my notes that I wrote for this was a plus 11, which makes this a much nicer problem, but we've gone this far, so we're just going to keep going. So x equals 7.375. In the actual problem, x is a lot simpler. It's SQR. It's 10. In the actual problem that I was supposed to use, it's 10, but that's fine. We're good. So that's not the answer. Sometimes the question will ask you for the value of x, and that would be the end. But this question is asking me for the measure of the angle SQR. So what I need to do is I need to plug that back in. So the measure of angle SQR is equal to 7 times this minus 5. And so I asked my handy dandy calculator for that information. I don't know, stop it. 7 times 7.375, and then minus the 5, gets me to 46.625 degrees. And that would be my final answer. Again, the actual one I was supposed to do with you was going to be 65, but sometimes the math isn't nice, and that's okay. A lot of times in geometry it is nice, but for right now it's not, and that's okay. Do you want to try one? Boop. I need some cool effects, you guys. Okay, this one, the key here is that this is a right angle. See a little box on it. So this is a right angle. Use that information to try to find the measure of EFH. Pause me so you can figure it out yourself. Did you get 60 degrees? Good job. If not, let me know and I'll give you more examples. So I know that these two add up to 90, so I combined like terms and then solved them to get that x equals 29. And then I wanted EFH, which is this top angle here. So I plugged in 29 into 2x plus 2 and I got 60. Mental math, so maybe I'm wrong, but you know, it's fine. So I hope that helps you learn the segment and angle addition postulates. And if you have any questions, come to my office hours, ask the FAQ, email me. I got your back. I'm here for you. Today, we're actually going to do some homework from the book, I think. I haven't made any other activities for it, but you can just click the link, the yellow box, and it'll take you to the textbook. So ask me if you have any questions. Okay, bye.